All right, welcome to another video. It's 5:41 in the morning, so what better time to go ahead and get started on this step-by-step verification for option B on this Interprovider Layer 3 VPN. Hopefully my audio is better. I actually learned today that you need to turn your headphones on if you want to use the speaker on them, so I did that. But let's go ahead and do the step-by-step verification. I had completed the configuration of the rest of the devices between videos. So let's see if it works. On PE1, we're going to look at the routes learned in the routing instance. So these are going to be learned from the CE router, which I'm on right now, through that Ospf neighborship. So thankfully, it looks like everything is all set. You'll notice we do have an extra route here. So let's take a look at that configuration on the interface. And sure enough, that's the same subnet that's configured on this interface. So from the previous video, we can hopefully figure out why that's the case. Well, I must be advertising direct routes into Ospf as well as just the route, the loopback route. So let's take a look at the policies and maybe compare them to what was in the example, and I might have added an extra statement there. So here's VPN. Why don't we go ahead and just double check the configuration of Ospf itself. And then we can see what kind of importing, exporting policies have been applied. So here you can see I checked Ospf just on the device itself, but of course, since we're concerned about the routes entering and leaving the VPN instance, that's what I'm going to check. These are for the core links facing the P router, but we need to check the side facing the CE router, which is going to be the doorway for this L3 VPN. So we'll need to do show configuration, routing instances, and then we've only got this one custom instance here. So let's take a look at that. So you can see there's a number of import statements. There's VRF imports here. There's also, so that's the only import statement, but we've got two exports, VRF exports. So here's the one for exporting routes into Ospf. So as I understand it, and of course that's the purpose of my studies now, is to make sure I'm really solid with this information. If we're exporting routes from BGP into Ospf, we're thinking about things happening this way. So from right to left, because this PE1 is going to learn routes from BGP, and its only BGP neighborship is with this Asbr1 here. So if you're looking at an export policy from BGP into Ospf, you're going to only be looking at routes coming in this way and then being advertised out to CE1. But we know that 203 route is configured here. So that's not going to be a route going this way because it's not even able to be sent. It's not even on this side of the topology. That's going to be a route going the other way. So we know we can pretty much ignore this. Let's just take a look at it to kind of get a better sense for it. We can see there's a policy statement here. So here we've got the whole thing. And sure enough, if it's from protocol BGP, we're going to accept it. And then in the actual routing instance itself, we're going to have those routes from BGP go ahead and be added to that routing instance. So we've got another one here that's all we're doing. It looks like if there's a route that's not from BGP, that's going to get rejected. But that's coming in from the right to the left. You can think about it that way in our real simple topology here. More complicated production, unfortunately, you can't really think of it that way all the time. But this is kind of a little bit of a tangent here. So anytime you're dealing with a complicated topology, you really want to do your best to write out the most simplified version of it that you can. So just do some sort of diagram or drawing like this, so you can go ahead and think about it in those ways. Use those tools to your advantage, traffic going right to left, traffic going left to right. That's really going to help you understand what is going on and what kind of configuration you need. So that's something I would always recommend to somebody, and something that was taught to me when I was in networking school, is simplify it and draw it out. But fortunately, the topology is already drawn out in GNS, so you don't really need to go the extra mile and do a hand drawing or anything. Although that can even be nice, because then you can add those extra details, port number, any extra notes that'll help you not have to go back and re-reference information you already looked at before. Okay, so let's take a look at these policies. So the export, that's going to be right to left, but we want to look at left to right. So we can see the import policy from protocol BGP. We're going to also check the community. So this appears to be right to left traffic. Let's see if this is more, and sure enough, this looks a little bit more like left to right traffic, because if it's from protocol Ospf, which is where we're going to be receiving that route from the CE1, in that case, we're going to go ahead and accept it into the VPN. So this is something I've always kind of struggled with. If you have a good mnemonic for this, or a way of understanding the difference between importing and exporting routes, help me out in the comments. But for now, I think it, for the most part, makes sense. As far as determining why we've got that extra route, we're going to have to look at CE1. So CE1, here we go. We've actually got the physical interfaces in CE1 as well as the loopback. And we are actually going to need that because we need to form that neighborship. So this is actually necessary. So it could just be that all of the required configuration does mean that the 203 route is going to be added there into the PE1's route table. At this point, I don't think that's enough of a kind of blip in the documentation to downvote that, especially since I'm not 100% certain that the configuration I entered is accurate. So first things first, I think I'm just going to go verify it quick. So here's CE1, and sure enough, we're adding both interfaces. Here's PE1, that's just the interface configuration, simple stuff. Now let's look at the routing instances, make sure that matches. So we've got instance type VRF. Here's something I wanted to mention before. So before I was more familiar with these configurations, I had to look up in the topology which interface is being called out here, because my naming is of course different. It's whatever my own devices have, and their naming for their ports is whatever their devices have. But as to whether it's the port on the left or on the right, that's something I had to look up and translate until I learned more about what this actually means. So this is for routes entering and leaving the VPN. So in your house, if you want to enter and leave if you want a guest to enter and leave the house, you would have them enter and leave through the front door and not the back door. And the front door is going to have extra things like the doorbell, welcome mat, those sort of things. So this is definitely the front door of the router. And of course, that's facing the CE1, the customer. So really, I no longer have to look up and translate this port, because I know that's always going to be the port facing CE1. And I have my topology so that GE000 is facing to the left, 001 is facing to the right. So I know right away the port facing to the left is facing my CE. And of course, it's flipped on the bottom. So this will be 001 here facing CE. But that is the port 000 for PE1, 001 for PE2 that will need to be added to the routing instance, because that's going to serve as the front door of the router. So yep, everything looks like it matches. Let's take a look at the protocols configuration. And you'll notice sometimes I'm forgetting that configuration. So if I'm in configure private mode, I don't need to add that extra keyword show configuration protocols. So you'll see me do that a lot, kind of forget to add that. That's because I haven't really transitioned mentally from configuration mode to non-configuration mode. So I don't know why this is there, but we can just ignore it for now. So let's check that all the protocols configuration is accurate. Here's a core link. So this is going to be in that same vein where I know what I want entering the front door of my house and what I want entering the back door of my house. That might be where I want. If I had pets, a dog or something like that, I'd want that to enter out through the back door of the house, just to go in the backyard. If I was having, just wanted to go in the back of my yard to do some exercise or mow the backyard, I'd go out through the backyard. So this is everything happening in the backyard of this router here. So you can see we've got RSVP, we've got MPLS, and these are all matching what's on here. You can see it's a different route, different interface than was in the front door. So front door and the back door of the router are different doors, and then they're going to have different activities moving through. BGP, this is for the back door of the router. We're going to have it to ASBR1. Everything looks good there. And everything looks good here. So I think it's pretty clear at this point. I'm going to keep checking. The policy options will be great to check, because this is where I was actually thinking that I might have added a statement to add the direct routes to the VPN, where the documentation here would not have told me to do that. So let's double check that. We can see I've got both of them here. They're going to be under the same hierarchy. So let's narrow that down. So we're just looking at the section listed here. Everything matches there. There's no extra direct route or anything. Let's take a look at the one for Ospf. So this is for things coming in from the back door, because we've only got that BGP connection, the BGP protocol operating between PE1 and ASBR1, which is the back door of our router. And now I'm welcoming front door entrance, the doorbell welcome mat to our customer. That's going to be protocol Ospf. And we can see all of the configuration matches. Let's take a look at the final policy statements. And sure enough, everything is all good to go. It's really all I need to check to be certain that my configuration is accurate. So yep, it's going to have an extra route the way they're saying to configure it. I don't think that's worth the downvote at this point. I kind of reserve that for a situation where I cannot proceed with the lab due to the documentation being inaccurate. So let's take a look at the next verification route. We're going to be verifying that router PE1 advertises the 192.0.2.1 route to Asbr1. So that's going to be the route on the loopback of CE1, just like we did in the last video with option A. So here's, if I use a question mark here, this is going to be the IP address of the neighbor. So in the back door of the router, here's where the house analogy kind of breaks down, because you're not going to have a fence. You're not going to not want to communicate with your neighbors. You're going to want to send and exchange information with your neighbors. So it's, a house kind of breaks down in this regard as an analogy, because we're not going to try to keep our neighbors away. We're going to keep in close contact with them and exchange lots of information. One of that being the loopback of CE1 that was learned through Ospf on PE1 and imported into the routing table for the routing instance that belongs to the VPN, the layer 3 VPN. And we can see, sure enough, it was, okay, so this is where I'm still not clear about. So we can see it was actually exported into the table. So you would think, hey, I received this route from CE1 and I want to send it out to other devices. I need to put it into this table. So I need to import it. I need to put it in. But unfortunately, just the way Juniper is set up, and I'm willing to cut them a bit of slack. They've got a lot of great features on the command line. You would use exporting to do that. So you would say, hey, I got your loopback 0 route CE1. Thank you. Now I'm going to export it into this table. I think maybe a better way to think about it is perhaps, thank you for your routes. May I share it with all my neighbors? Oh, I can. Okay, well, let me send it out to my neighbors and therefore export it out to my neighbors. I think that's perhaps what they were getting at with that naming in a much better way to think about it. I was thinking of it more, I have a L3 VPN bucket, and then I'm going to ship this bucket or bring it over to my neighbors. So I've got to import your route you gave me in order to put it inside that bucket so I can send it out to my neighbors. But I think what they were thinking more with this command is, thank you for your route. Now I'm going to export it over to my neighbors. So that's, I think, a much more useful way to think about how to add those routes received from OSPF, whether or not it was the way the person who chose what kind of verbiage would be used had intended for you to think about it. So this route here is actually exported into the VPN, the layer 3 VPN from OSPF. So here's the IP address of the ASBR1 neighbor, BGP neighbor. We're going to take a look at which routes are being sent over to that neighbor. You can see this is being sent over to that neighbor, so you could say it's being exported to that neighbor, so it makes perfect sense that you'd have to add it as part of an export policy into that VPN. Everything looks the same. We're going to get a different label. Looks like we got 16 again this time. Same one we got in the last example. So it looks like we've got a different neighbor here. And that's, of course, going to be because they want us to switch over to this other router here. this one will not have that neighbor. In fact, that's going to be the virtual configuration by match. Oops. Yep, as you can see here, that's going to be the loopback 0 address on this. So here we're looking from left to right over to ASBR1. So let's jump over to ASBR1 and take a look right to left over to PER1. So now we're in the backyard of PER1. A lot happens back there. There's a whole city to explore. And here we can see they really are only interested in this BGP L3 VPN table. So let's go ahead and narrow that down. Could not resolve the name. So question mark, best friend. And I kind of know, yep, there I see it. So table, BGP, L3 VPN.0, extensive. Now we got only the relevant information. And you can see the route distinguisher is added to this entry. Everything looks good. Let's take a look at the next command. On these ASBRs, we're going to have two BGP neighbors. Take a look at the summary. We're going to have a right to left neighbor, and we're going to have a left to right neighbor. So the right to left, thinking in terms of the topology, is going to be to PE1. But then we've also got a left to right to ASBR2. Looks like in my case, I've got a third neighbor as well. So, and that is in idle. So I'm not sure what is happening there. It looks like I've only got statements set up to .6. I don't have any statements over to .8. So how it is actually forming that neighbor, I'm not certain. Why is it? It is attempting to form that. Okay, so I can see it here. There's an extra statement here saying to go to a .8 neighbor. So maybe that just needs to be .6. I'm going to go ahead and verify that. On ASBR1, let's take a look at what was meant to be entered for the routing instance. So it looks like there actually wasn't meant to be a routing instance entered on ASBR1, so I might have just gone ahead and forgot to tear that down from the first example, something like that. But since that is not necessary, I can just delete it. You can take a look at my interfaces. Oh, and it looks like, sure enough, I did forget to clear it down from the first example. So one thing that I think will immediately jump out to anyone who's familiar with Cisco's but not familiar with Juniper's is I've got two host addresses from the same subnet on one interface, and that's really not meant to be something that's possible on a Cisco. You'll get an error message if you try to do that. You can have a secondary address on there, But even then, and I'm not sure about this, you might not even be able to have a secondary address in the same subnet. That's something I need to verify to say for certain, but you can see on Juniper's that's quite a bit different. You can have that sort of configuration. But in this case, we will need to get rid of that. Oops. So .6 is the extra one. Okay, and now we'll need to get rid of the extra one on GE001. And that's going to be .3.7. All right, and the loopback address looks good, so let's go ahead and commit that. Take a look at the protocols configuration. Let's go ahead and narrow this down some more so it's not as much output that's irrelevant. So everything looks great there. Let's take a look at the BGP configuration. Everything looks good here as well. So this is the facing PE1, so it's going to be the iBGP configuration. Let's see here, type internal. So let's take a look at the eBGP configuration over to ASBR2. Type external. All right, everything looks good there. So let's go ahead and go back and then go to the VPN operation, verifying the VPN operation. And hopefully that first part where there was unexpected information is now resolved. So let's just go back through all the commands and enter them in. You might even see some disappear from PE1. Looks like right now the instance for Ospf is no longer, oh, okay. So we tried to check a routing instance, but did that on CE1, so that L3 VPN is not going to be on CE1, it's just customer router, really don't have a say in what goes on there, really. The ISP will have a layer 2 device somewhere here so that they can put QoS on there so that they can kind of, I think it's mostly for QoS, some monitoring so that they kind of know more about utilization. But this device here is going to be owned by the customer, so there's really nothing to look at there for this exercise because it's geared more towards the provider. So we still got that extra route on there, that's fine. We're going to look at the routes sent from left to right over to the Asbr router. And sure enough, we're sending that loopback address from the CE. Perfect. Now we're going to look at the routes received from left to right. And this is something I struggled with a few videos back. Kind of the difference between receive and advertising. So we are still looking from left to right, which makes sense because the focus of this exercise is that route on loopback 0 from the CE router. So we would be continually needing to look from left to right. So let's look back at the PE1 neighbor, but we're going to look at the routes that we received from that PE1 neighbor. So it's still going to be looking from left to right. So sure enough, we've received that loopback 0 address from the CE router. But what's interesting is we didn't receive it in the INET table. We received it in this BGP L3 VPN 0 table. And we didn't exactly receive the route. We received the route with the route distinguisher attached. So you see the route distinguisher is 1:100. So instead of just receiving this 192.0.2.1/32, we received 1:100:, and then that route. So if I show route, it looks like that .1 don't even have that in the routing table. 192.0.2.1, even though it's here in the BGP table, it's not in the regular routing table. Well, we can see 2.1, even though it's not in any of these tables here, we do have it here in the L3 VPN table, which makes a lot of sense because it was exported on PE1 from how it was received as a OSPF route into the L3 VPN, which is running BGP, and which is going to append this route distinguisher onto the route. So we're really not receiving a route exactly anymore, at least not the way we would in the INET.0 table. We're receiving more of a kind of extra enhanced route from the L3 VPN that's got this extra information in front of it that was added by PE1. So let's take a look at the next command. Let's take a look at the extensive version of that command. So in the previous command, I'll up arrow to that. We can see we were looking left to right, and we were looking at what was received from PE1. And sure enough, this route here, the kind of enhanced route from the L3 VPN with the route distinguisher in front, was received from PE1. But now we're actually going to continue looking from left to right. We're just going to look a little bit ahead and see what is being advertised from this ASPR. So we're no longer standing off the cliff looking at things being thrown toward us. Let's say that we're playing baseball and catch with somebody. So we're no longer looking to catch the ball from somebody and seeing what that looks like. So we're catching the ball. We're going to receive the ball here. So what does the baseball look like if it's being thrown to us by somebody else? Well, it looks like that. But But what does the baseball look like as we throw it? It's going to look like this. So it is going to look quite a bit different, because when it's being thrown to us, we get the name of the person who threw it, which is the BGP L3 VPN. So router PE1 threw it, and the way they threw it is by sending it through the L3 VPN. But when we go ahead and throw it to the next person, we're going to see that we're doing that to ASBR2, and we're actually moving it to a different BGP group. So I do show configuration, display set, match BGP. Two different groups here. We've got the group P1, the P2. So when we catch the baseball, it's going to arrive in through this BGP group. But when we throw the baseball, it's going to be sent out through this BGP group, even though both groups are going to be in the same BGP table. All right, let's take a look at the BGP summary quick, just to make sure those are now established. Yep, so that error I had on PE1 with the extra IP addresses, that's the sole cause of the issues that we're having here. So we're good to move on to ASBR2 now, so that those are resolved. So we're gonna take a look at a receive protocol. So we're gonna be thinking about catching the baseball right now. And who are we gonna catch the baseball from? We're gonna catch it from ASBR1. So let's see what that looks like when we catch that. And let's see what the baseball looks like. So this is what it looks like. It's got that extra route distinguisher added to it. It's in the BGP.L3 VPN table. Very nice. It's got a next hop assigned to it, which is going to be where we received it from. So that's talking about more going the other direction. Right now, we're really not talking left to right or right to left. We're talking top to bottom because of how these are happen to be listed in my topology. So let's go ahead and run the next command. Well, before doing that, let's think a little bit more about this BGP.L3VPN.0 table. So I'm going to do a show configuration, display set, no more, match. And before I do that, I'm going to open up PE1. And then I'm going to look at the configuration. And you can see, yep, there's a routing instance there. So if I match, so I need to show configuration, routing instances, type display set. And yep, here's the front door of this topology with the welcome mat and doorbell who we're exchanging routes. So the question here is, do we have that sort of thing on the ASBR? So I'll give you a moment to think about it. All right, time's up. So let's see if we've got that configuration on here. And sure enough, we don't have it. So the traffic isn't going to be leaving or entering the L3 VPN here. It's just going to be crossing autonomous systems. So these here, these three routers, and then these three down here are what is representing the interprovider VPNs. And you can see I actually have this label here. I didn't update that. So this is going to be for interprovider VPNs, and then you're going to have two internet service providers, the one up here with a autonomous system. It's going to be autonomous system 100, and then the one down here with autonomous system 200. So you're not going to be taking the routes out of or putting the routes into a L3 VPN here. You're just going to be exchanging the routes with another internet service provider. So on ASPR2, we took a look at what the route's going to look like when it is received from the provider in autonomous system 1. So we're still going to receive it in a L3 VPN. It's still going to have a route distinguisher. AS path is going to be from AS100. So let's take a look at what it looks like when we throw the baseball instead of catching it. And you can see now we've prepended AS path on there, 200, since we're now at 200. And we're going to PE2 now. Okay. So let's jump over to PE2 and check that. And this is going to be receiving the baseball. See what it looks like when ASBR2 throws us the baseball across the park. So we get it in a few different ones. So we get it the way the ASBRs have been receiving it, which is this BGP L3 VPN, and kind of similar to how there were multiple groups, BGP groups. So I'll show configuration, display set, match, BGP. We've also got multiple BGP groups on the PEs, but now we've got them separated into different routing instances. Into the default instance here, we don't even need to specify that it's in a special routing instance because it's going to go into INET 0, or, well, it's going to go into BGP dot. Well, this is something actually I am not sure about. We obviously see that it is in this BGP.L3VPN.0 table, which is going to be, I believe, the default, because it's going to be received as a L3 VPN. Okay, so here's where this family, so this is something I really haven't talked about much, but this is how we know that it's going to be in this table instead of a table like INET 0, even though INET 0 is the default table. So a good question to ask would be, oh, well, why is it in a special table? Why isn't it in INET 0? We didn't actually specify for it to be in a special table. This the same way we did down here. We said set routing instances VPN2 C2. So we told it to be in a special table, this VPN2 C2 table. We can see that happened up here, but we didn't tell it to be in a special table when we did set protocols BGP. It's just going to go into the regular INET.0 table. Well, that's where this comes in. Family INET-VPN unicast. We actually did tell it to go into a special table with that. We're telling it to only process INET-VPN traffic, which are sent to this BGP L3 VPN table. So that I think an accurate explanation about why this is not going into inet.0 and why it's going into this special table here, even though we didn't set up a routing instance to build that table. It's a default table, but it's associated with inet-VPN unicast traffic. All right, so moving on, we're going to be looking at what happens when this throws the baseball. So what happened when it received it, so it actually caught it from ASBR1 in its right hand, and then it took it out of the baseball glove with its left hand. It looks like it's a left-handed thrower. And now it's going to throw it over to CE2 with its left hand, and it's going to throw it out of this special table. And we saw on ASBR, kind of did that same thing, caught it and threw it with another hand, but it was just across BGP groups and not different routing instances, one of them being the default routing instance for inet-VPN traffic, the other one being a custom defined one for this L3 VPN. So when we throw the route over to the CE1, you can see the route path here is going to track the whole chain of the baseball team who threw it. Started with Timmy, he threw it to Bob, and then Bob threw it to PE2. So Timmy was the internal AS. Bob was in AS 100, and we're in AS 200. It's a new, this is the one it's in currently. This is looks like it's an external BGP group. So this is the connection to CE2, just like in the first example. You're going to have the connection from CE1 to PE1 be an Ospf connection, but down here it's going to be a BGP connection just for some variety and kind of learn both protocols at once. So our final step is to verify that it made it all the way down. Sure enough, it made it all the way down from CE1. We can see the path it took to make it down there. It started, open up the topology, it started as an internal BGP route somewhere here. And then it went through AS 100 here, went through AS 200 there. So everything looks good there. A ping will be able to work. Sure enough, we've got a ping working. And in the same vein as before, if I don't include the source address in that ping, it's actually not going to work, because let's take a look at PE1. Sorry, PE2, and we'll see that the source address, we can see it's via this port here, it's configuration int. So we can see what the source address is going to be. It's going to be this 6.14, which is a, and we'll take a look at the routing table entry for that. And that's sure enough a local route, directly connected. So let's take a look at the longer prefix for that. So we can do show routes. And this is something that is assigned to the actual interface. So it's the longest prefix, it's a /32, and it's a local route, but we want to look at the connected routes. So looks like there's no way to just look at a longer prefix, but here's an example. You can just do one that is not assigned, and then it will automatically go to show you the subnet. And then, of course, we knew what the subnet was already, so we just look at that and see, yep, this is a direct route. So we go on PE2, show insertions, take a look at the interface to CE1. You can see this is going to be a direct route as well, but we look at the configuration of what is being imported or what is being exported. So we're going to catch the baseball from CE2, and then we're going to pitch the baseball over to the other routers. So we're going to export the baseball from CE2 out to the other routers, and then we're going to import the baseball from the other routers in. So let's take a look at this. And what we're looking for is the absence of protocol direct. You can see we're only accepting protocol BGP, and then we're rejecting everything else. So sure enough, this direct route here, we try to ping without specifying that source route like we had here, not going to be successful, and that's going to be because there's no routes to the host. So if we do a trace route, we're going to make it across to the other .13 that we saw here, but as we can see, it's not going to be anywhere in that L3 VPN table. And here, or sorry, down here, it's not going to be in this table anywhere. And this is going to be .6.0. I actually do see it in the table here as a direct route and a BGP route. So it did actually make it in there, but we're not exporting it from this table to this table. We can see we didn't dress it up with a extra route distinguisher or anything like that. So let's actually take a look at what happens when I import it. Is it going to be added to this table with a route distinguisher? Okay, so set policy options, policy statements, VPN exports. Let's just go into the hierarchy for that. Do a show display set relative, and now let's edit term 1 and add protocol direct. Take a look at those routing tables again and see what the differences are there. So looks like it's still not in that routing table. Looks like there really aren't any major differences. So let's go ahead and see what happens when I add it to the import instead of the export. And let's see right now if I can trace routes. Let's just see if I can ping first using that other source address. And sure enough, I can, so there's no issues with it. So there's really no sense in seeing what it looks like if it's imported instead of exported. So unfortunately, this is another situation where I'm not sure why there's no differences in the routing table. A good trick I can do is just take the whole routing table down from the cursor here up to the cursor here where I ran it. I can open up Notepad++ here. And now I can open a new tab in Notepad++. I can go into configure private, pull back one, compare. And now we're no longer going to be exporting into the VPN export policy. We're no longer going to be including direct routes in that. So if I go back here, you can see I can no longer ping. So let's print out the routing table again. Copy it. Oops. There we go. And now paste it into the other tab in Notepad++. Select the first one, go to plugins, compare. And we're going to compare the two files. So we can see all the timestamps are going to be different. That's of course to be expected. So looks like as of now, that's really the only difference. It's just the timestamps. So yeah, we can see that's pretty interesting. The only thing that, so I created that policy. It actually didn't change any information in the routing tables at all, but it caused an additional route to be able to be used as a source address. So that's very interesting. I was not expecting that. Let's go ahead and clear the compare. I wish this was in a better color so I could go ahead and read what was under there. There might be some changes that I can't see because of the color highlighting. But let's go ahead and clear that compare. Move this to another, move it to a other view, to the other view. Kind of look at that more closely. Unfortunately, with those coloring rules set up, compare wasn't quite as useful as it would have been. But just at first glance, we can see, sure enough, the only differences on those lines were the timestamps. So some way or another, even though the routing tables did not change, the behavior of the routing did. So that's definitely something to look into, figure out at a closer level. Good topic for another video for sure. Next video is going to be a Wireshark capture of all the links, and then we'll get to C, to option C, and then we'll hopefully be able to move on to another topic as soon as possible. There's 80 topics on this exam, so we kind of got to keep moving through them pretty fast to get to all 80 before the exam starts. So unfortunately, there are some situations where I would love to dive in as deep as possible and figure out what is going on, but if I did that, I'd really only be studying a small handful of the topics on the exam, and I want to get to all 80. So thank you for watching, and join me in the next video for the Wireshark analysis.